is Amber Kilman, and this is my presentation for my Cap 1 assignment for ATP Pathways. So, there are two different pathways that we are going to be talking about today, and these pathways are glucose and fat. So, during the process of glucose, we have glycolysis, citric acid cycle, and the electronic transport chain. For the fat, we have B-oxidation, the citric acid cycle, and the electron transport chain, and the activation of fatty acids. So for my diagram, we are going to start with glucose. When we start with glucose, we go into what is called glycolysis. During glycolysis, we get these little tiny cells called pyruvate. We have to create two sets of 3 pyruvates. So here they are our little pyruvates. So during this process, you get 2 ATP, which is 2 pyruvates for 2 NADHs. The pyruvates then turn to acetyl-CoA. So after the glycolysis, we have the citric acid cycle. So during the citric acid cycle, we get 6 NADHs, we get 4 ATP, so we end up getting 10 NADHs. And then we also get 2 FADH2s, which equals 4 ATP. So after we get done with the citric acid cycle, we go into the electron transport chain. During this chain, we get, from our 10 NADHs, we get 34 ATP. And from our 2 FADH2 from the citric acid cycle, we still have 4 ATP. So when you add those together, you get a grand total of 30 ATP created during the glucose cycle. So during the fat cycle, which we're going to talk about next, we go into what is called B-oxidation. And for this, we go into it for 7 rounds. So during these 7 rounds, we get 1 NADH, 1 FADH2, and 1 acetyl-CoA. So after 7 rounds, we get 7 NADHs, 7 FADH2s, and 8 acetyl-CoA. Then we go on to the citric acid cycle. During this cycle, we get 24 NADHs, 8 FADH2s, and 8 ATP, which turns in. So from that, we get 31 NADHs, and then we get 8 ATP. After this, we go on to the electronic transport chain. During this process, we get a grand total of 131 ATP from this part of the process. After that, we have to activate the fatty acids. So because of that, this cost us 2 ATP to do. So at the end of the fat pathway, we get a grand total of 129 ATP. So just to recap, for the total ATP of each pathway, for glucose we get 38 ATP, and for fat we get 129 ATP. So how does this all work when it comes to interacting during exercise intensity and duration? Well, it turns out these pathways actually work simultaneously, like my diagram previously showed. So here's another diagram that we show of the process. So during the ATP process, when glycolysis is occurring, so right here, there are 2 types of fat that are triglycerides. So glycerol, right here, starts in the glycolysis process and turns into pyruvate. Okay, so during glucose and fat, they both start in the glycolysis, which then glycerol goes into glycolysis to become pyruvate. As the pyruvate breaks down, just like in the glucose, in fat as well, the fatty acids also become acetyl-CoA. So this in turns these end up becoming the same process because they have to go through the citric acid cycle and the electron transport chain in order to produce ATP. So this is how they work simultaneously when we are performing exercises. So the primary factors that limit ATP production and exercise for each pathway. So during extreme exercise, according to our textbook, Exercise Physiology, Nutrition, Energy, and Human Performance by William D. McErdle, Frank I. Catch, and Victor L. Catch, only under extreme conditions of physical activity do ATP levels in skeletal muscles decrease. When exercising at a high intensity, it does take longer for fat to break down than it does glucose. ATP can't be created fast enough with fatty acids, so that's why during the speed of processed fat can only be used during moderate exercises. The duration of exercises too as well. The fuel doesn't last long during the glucose part of the process. So glucose makes enough ATP to last, but it doesn't last as long. The fuel doesn't last long enough to go through the process. More energy is needed. So how do we apply these in the real world? Well, these pathways are needed for us to have energy. According to the article, Is Body Composition Important for Pediatricians by Jonathan C.K. Wells and Mary S. Futrell, they found that measurements of lean mass may improve the capacity to tailor nutrition, treatment, and management to metabolic criteria. Excuse me. So by exercising and moving, energy is created. By not exercising, we're not able to create the adequate energy we need to be healthy. Diseases such as type 2 diabetes and cardiovascular disease and hypertension could occur through poor exercise routines. So it is important to remember to exercise regularly to keep making enough energy for us to get through the day. So for these pathways, we need their energy in order to move. So me just talking and moving during this presentation or going to make a meal, we use energy to do those things. So if we're just sitting on the couch all day and we're not doing anything, we're not creating the adequate enough energy we need to make it throughout the day. So it is important to exercise during the day in order for us to have enough energy to make it through the entire day. So what does it mean so we can sustain movement and exercise? Well, ATP not only releases energy, but also stores energy. So both pathways will help with exercise in some way. So glucose helps with intense exercise, and fat is great for moderate exercise. So both the pathways help us when it comes to exercise, but they both help for different ones. So glucose helps for the most intense exercises, while fat is only for the slow, moderate exercises. We can't rely on the system that produces the most ATP. So it turns out fat actually creates more energy than glucose, but we can't rely on that to produce enough energy for us to make it throughout the day. So the power generated solely by fat breakdown represents only about 1/2 achieved with carbohydrate as the chief aerobic energy source. McErdle et al., page 158. Glucose has enough energy available for us to use, but fat, we cannot rely on it because of how slowly it breaks down. So like I had stated before, fat breaks down too slow for us to be exercising. That's why when we exercise, we use glucose for the intense exercises, and that's why fat is only used for the moderate exercises. So we can't rely only on fat for us to do exercises. Also, back to the diagram as well, these systems work together intermittently for us to be able to create energy. So without glucose, how are we supposed to rely solely on fat to help us with our energy? This is why we need both, and we can't just use fat even though it produces more energy than glucose. They work in together for us to have energy to make it through the day. Sorry. Alright, these are my references. That was the end of my presentation. I hope this helps clear up on how different the ATP pathways work, and I really hope you enjoyed.